In number 5, you are asked to solve the quadratic equation. And actually, we can see this is x to the 4th. This is not actually a quadratic. It's a quartic. But we're asked to solve this equation. So let's remember that sometimes we can solve by factoring, but not always, and that's generally the easiest method or the quickest method for students. If you can't solve by factoring, you can always rely on the quadratic formula or completing the square method to solve. So let's see if we can factor and solve this. 3 times negative 8 is negative 24. I want to think of two terms that multiply to give you negative 24 and combine to give you positive 10. And that is possible, so I can factor. That would be x plus 12 and x minus 2. Just going to make sure. Multiplies and combines. Now, this is a 4, so I need to split that 4 in 2 and 2. Split the 4 in half, giving it 2 and 2. A big mistake when students are hurried is they often forget to do the bottoms-up method. So I'm going to put a 3 underneath both, and then I'm going to reduce the fraction if possible. The last step is I'm going to take each one of these and set it equal to 0 and solve. So I'll start with the first parenthesis. Move 4 over to the opposite side by subtracting. This tells you you're going to have two answers. So two answers come from a plus or minus. You cannot take the square root of a negative. It comes outside and becomes an I. And the square root of 4 is 2. So two answers, one is positive 2i and one is negative 2i. Remember, it looks like I'm going to have 4 answers. There's 2. Here's the next portion. I'm going to take x squared minus 2/3 and set it equal to 0. When I move a negative 2/3 over, it becomes positive. Tells me I will have two answers. I square root both sides. And don't worry about rationalizing the denominator. We're going to have one answer that's a positive, the square root of 2/3, and one's going to be the negative square root of 2/3. Moving on to number 6. Same directions. We're going to solve for x. So I'm going to start by foiling this portion. If you've forgotten what FOIL means, it means multiply the fronts. O means multiply the outsides. I is multiply the insides. And L is multiply the last terms, or the final terms there. Now I'm going to combine like terms. So before I even combine these, I'm going to move these two terms over so I have everything on the left-hand side. So to move over a positive 11x, I'm going to subtract. To move over a negative 1, I'm going to add. And now I have 12x squared, combining these three terms because they all contain an x. X, negative 2 and 18 is 16, and positive 16 and negative 11 is 5, positive 5. So remember, solve. You have three options. You can solve by factoring if it's possible, but it's not always going to work. But you always can use the quadratic formula or completing the square. Generally, solving by factoring is the fastest method. So let's check to see if this is factorable. 12 times 3 is negative 36. Is it possible to come up with two terms that multiply to give you negative 36 and combine to give you 5? And I forgot again to combine these two terms. I just automatically brought down the negative 3, but I forgot to combine it with the positive 1, making this a negative 2. Let's go back. 12 times negative 2 is a negative 24. Okay, so two terms that multiply to equal negative 24 and combine to give positive 5. 1 and 24, no. 2 and 12. 3 and 8. 3 and 8 do work. Positive 8 and negative 3. Multiply and combine, that does work. and I split this 2 in half to get x to the first and x to the first. Now do bottoms up. Reduce each fraction as possible, so divide by 4, divide by 4, divide by 3, divide by 3, and now I'm going to set each one of these equal to 0. And you can do that, or recognize when you don't have a square here, you can just circle and go, okay, one answer is negative 2/3, and the next answer is positive 1/4. Algebraically, it looks like this. Set it equal to 0, move it to the opposite side. There's your first answer. Set it equal to 0, move it to the opposite side. There's your second answer. Okay, find number 7. Solve the quadratic equation showing all work. Again, we will first attempt to solve by factoring. If factoring does not work, then we can try either the quadratic formula or completing the square. Okay, so let's see here. 8 times 5 is 40. Can I think of two numbers that combine to give you positive 40? And sorry, that multiply to give you positive 40 and combine to give you 6. So 1 and 40, no. 2 and 20, 4 and 10. Most students are going to say 4 and 10 work. But realize if you use a 4 and 10, it would have to be a positive 10 and a negative 4. That would give you a positive 6, but it would not multiply to give you a positive 40. So not possible. So now we can choose to use either completing the square, or we can choose to use quadratic formula. Either one will give you the correct answer. It's more of a personal choice. I'm going to do completing the square. All right, here we go. So I'm going to have 8x squared plus 6x, and I'm going to move the 5 to the opposite side. Then I'm going to factor out an 8. So 8 divided by 8 is 1x squared. 6 over 8, remember the x. Then I'm going to eliminate the 8 that's on the outside by dividing. So divide both sides by 8. And when I rewrite this expression inside down, I'm going to reduce the 6/8. So 6 divided by 8 equals 3/4. Okay, so take the b term and divide it by 2. So I'm going to take this term and divide it by 2. So you're welcome to use a calculator to do that. 3 divided by 4, and then divide it by 2 and turn it back into a fraction. Recognize that this 3/4, when you divide it by 2, you're just going to double the denominator. So 3/4 becomes 3/8, you just double the denominator. There's your positive sign and 3/8. Now I need to go back and fill in these positions. So in this position, I take whatever this is and I square it. 3 times 3 is 9. 8 times 8 is 64. So I'm going to take this and rewrite it over here. Using a calculator to combine the two terms, I'm going to combine a negative 5/8 and a positive 9 over 64. And then I'll turn it back into a fraction to get negative 31 over 64. Solving for x, the next step is to eliminate the square. Opposite of squaring something is the square root. Remember, this means we're going to have two answers. So I get to put a plus or minus in front. Then I eliminate the square and the square root, and I have x plus 3/8 equals plus or minus. Now I can't take the square root of a negative, so the negative comes out and becomes an I. The square root of 31, don't know it. The square root of 64 is 8. The final step is to take the positive 3/8 and move it to the opposite side. When this moves over, it stays in front of the plus or minus. So it was a positive 3/8. I'm going to subtract and move it to the opposite side, with the final answer looking like this. X equals, again this moves over, becoming negative 3/8 plus or minus I square root of 31 all over 8. Again, and why is there not a square root that is connected or covering the 8? Because we actually evaluated the square root of 64 is 8. We don't know the square root of 31. It's irrational. Going on to number 8. So we're going to solve this quadratic. Remember that we can try factoring. That's generally the quickest method, but it doesn't always work, as we saw in number 7. If it doesn't work, we can do completing the square or the quadratic formula. This says write this twice, x minus 2, x minus 2. Now I'm going to FOIL. FOIL means multiply the fronts, multiply the outsides, multiply the insides, and multiply the last numbers. Then I'm going to combine like terms. So I'm going to move everything over to the left-hand side. To move a positive x, I subtract it. To move a negative 11, I add it. So there's nothing left on the right-hand side. On the left-hand side, I'm going to combine like terms. Only 1x squared. Combining these three terms, negative 2 and negative 2 is negative 4. Negative 4 and negative 1 is negative 5x. Plus 4 and 11 is 15. That's a big equal sign. Okay, so x squared minus 5x plus 15. So can I think of two numbers that multiply to equal negative or positive 15 and combine to give you negative 5? So 1 and 15 work here but don't work here. 3 and 5 work here but don't work here. Okay, so it's not factorable. So what do we do when it's not factorable? Either completing the square or the quadratic formula. This time, since I showed completing the square up above, I'm going to do the quadratic formula. So just give me a little more space, 1 second. I'm going to write down x squared minus 5x plus 15. X squared minus 5x plus 15 equals 0. And again, you can't use the factoring method. You could definitely use completing the square. I'm just showing another method, so I'm going to do quadratic formula. You do have to have this formula memorized if you choose to use it. A is 1, B is negative 5, C is 15. So B is negative 5. Big mistake students often forget is they forget there's already a negative there. So this negative that was already there combined with the negative 5 is actually going to give you a positive 5. Negative 5 squared minus 4 times A times C all over 2 times A. 2 negatives make a positive. 2 times 1 is 2. Okay, I'm going to do this whole portion called the discriminant on the calculator at the same time. So, here we go. You know, you have to use parentheses when you plug this in. I'm working with this portion. Parentheses, negative 5 squared minus 4 times 1 times 15. That number is going to be the discriminant, the number underneath the square root. So negative 35 is the number. We know we cannot take the square root of a negative. Remember that this has to be shared with both terms. So really it looks like this. 5 halves plus or minus. Again, you can't take the square root of a negative. It comes outside and becomes an I. Square root of 35 over 2. The only last question is there a perfect square other than 1 that divides nicely into 35 that would reduce it? So 4 does not divide nicely into 35. 9 does not. 16 or 25. This is your final answer. Two answers, one time adding, the second time subtracting. Okay, number 9. Number 9 has two parts, the part we can see and then your explanation is next. It says which one of the equations in problems 5 through 8 that we just covered produced a complex solution, and explain why the equations have a complex solution. All right, so the complex solutions are the ones that have a final answer that has an I. Now, the reason for the answers, we have problems 5, 7, and 8. 5, 7, 8. Let's talk about number 8. So this is problem 8. This is a complex solution because it has an I. Now, what led to it being a complex solution? We were asked to take the square root of a negative number, which is not possible. So the negative came out in front of the square root, becoming an I, which makes it now imaginary and complex. The same thing happened in number 7. In problem 7, number 7 has an answer that has a complex solution. And the answer is what led to this? You're asked to take the square root of negative 31. Can't take the square root of a negative, so the negative comes out front, becoming an I. That's now imaginary, and we have a complex solution. Number 5, 2 of the answers are complex. What led to these being complex? You were asked to take the square root of a negative number. The negative had to come out first before you could take the square root. When the negative came out front, it became an I. An imaginary number becomes a complex solution.